Hello students, welcome to my channel. Mm, Today we are going to discuss numerical problem practice on Coulombs law. The basic things about the Coulombs law and the vector formation of the Coulombs law I have discussed in my last video. In this video we are going to discuss the three uh, three numerical problems based on that concept which I have discussed already in the last video. So one by one I'm going to start. So the first sum which I'm going to take is very simple level sum in which we are going to find only the force. Okay, so what is the force between two small charged sphere having charges of 2 into 10 raised to power minus 7 coulomb and 3 into 10 raised to power minus 7 coulomb placed at 30 cm apart from 30 centimeter apart from each other in diagonal. So when I say that this kind of force if I want to calculate, so very easy it is, how to do this. If you know the Coulomb's law very well, you can directly implement the formula of Coulomb's law over here and you can find it out. So what is given content here that let's say there are 2-point charges, because as it is given that the point charge, as it is given that the charge pairs are very small, so you can consider that as a point charge. So let's consider that I can consider here there are 2-point charges q1 and q2. Now let's consider the distance between them is r. So these values are given. So what is q1 is 2 into 10 raised to power minus 7 coulomb, and the q2 is 3 into 10 raised to power minus 7 coulomb, and the distance r is 30 centimeter. So it is very important to convert the distance r in the MKS unit, because everything we are going to calculate in the same unit system that is required. I think it is very clear from your side also that we need to take each unit of each quantity in a same unit system. So it is it should be written in meter. Okay, after that, to find the force, we need to apply the formula of Coulomb's law here. So since by Coulomb's law we know that F equal to Q1 Q2 upon 4 pi epsilon naught r square. Here it is very important to know that since in free space 1 upon 4 pi epsilon naught is given by 9 into 10 raised to power 9. That how this value is coming I had discussed in my last video. If you want, you can look if you can watch my last video also. So there I explained that how it is going to come, and just put this value in this formula. So since 1 upon 4 pi epsilon naught is equal to 9 into 10 raised to power 9, so I can say that it will be coming in the numerator. So I'm putting all the values of charges and all given values here, and we'll be finding the force. So it will be 2 into 10 raised to power minus 7 as a q1, and 3 into 10 raised to power minus 7 as q2, and into 9 into 10 raised to power 9, because it will come in numerator, and in the denominator I can put 30 into 10 raised to power minus 2 all square. So now what I want to do, I just want to solve it and find the answer. So here when I solve this, if you don't have calculator, let's suppose, then what we need to do here, we just have to write separate out the numbers like this, like 2 into 3 into 9, and then I can separate out the 10 raised to powers in right hand side, so that it will be easy calculation. And then in the denominator I can also write 3 into 3 as it is square, and 10 raised to power 2, because there is a 30, so there will be a 10 raised to 2 extra, and then 10 raised to power minus 4. So when I solve it, I'll be getting here what I can say, that this will be cancelled out, and I'll be getting 6 here and 10 raised to power minus 3. So my result is this, and as the force unit is Newton, so I can write here my force value will be Newton, or I can also write 6 milli-Newton, as 10 raised to power minus 3 is there. So this is the answer of the question. This amount of force will be there in between these 2-point charges. Hence you can apply the basic Coulomb's law to find the the charge between the force between 2 point charges. So this is very basic level sum. Now we switch to the next sum. There is some advancement, like we'll be discussing the vector form of the Coulombs law here. Now let's discuss this question here. The question is, well, there are 4 point charges QA, QB, QC and QD. These are the 4 point charges QA, QB, QC and QD, and these values are given 2 microcoulomb, minus 5 microcoulomb, 2 microcoulomb and minus 5 microcoulomb respectively. So they are located on a square of a corner of a square. So like there is a square and there are 4 corners, as you know that. So on each corner there is one point charge is existing, and we need to find the force on charge which is of 1 microcoulomb, which is at the center of the square. So now the point is what, here in this kind of question we need to interpret some geometry. So like this geometric interpretation should be known very well before we solve this question, because the very important factor in Coulomb's law is the distance between the point of observation charge and point of the point charge on which we have to find the force. So what we can do here, that I'll be imagining one square here like this, and then I'll consider there are 4 point charge on each corner like this. So this is my imagination as per the given information, and let's start with this point A, this point B, this point C and this point D. And similarly you can place the charges QA, which is equal to 2 microcoulomb. Here you can place QB, which is equal to minus 5 microcoulomb. This is QC, which is equal to 2 microcoulomb, and this is QD, which is equal to minus 5 microcoulomb. Now the question is, there is a point which is called center of the square. On that 1 microcoulomb per charge is existing, and on that point you need to find the force due to this all point charges. So here we'll be using, no doubt he'll be using mathematically you should use the superposition principle of the Coulombs law, but there are some more methods, because sometimes in the competition exam, if this kind of questions are coming, we won't be getting that much time to solve this question. So we need to understand the symmetricity of the question, and directly we should answer. So I'll be explaining this question in 2 forms. One is very like how you can solve in very lesser time, and then I'll explain this same question by using some vector geometry also, so that subjective answer should be there. That's why also I'll be solving the same question in a different method. So let's suppose that to find the center, so if you geometrically interpret this, we know that the center point of a square is also the intersection point of diagonals. So if I trace the diagonal, 2 diagonals here, so this diagonal is the center point over here, and this is the intersection point of this diagonal is also center point of the square. So let's suppose this point is given by point O. Okay, so over here the charge which is given is Q naught will be equal to 1 microcoulomb, which is existing over here. So what I can do here, so just consider point O and the Q over here, and the Q naught is equal to 1 microcoulomb, let's consider, which is at O. So very important point, that if I want to solve this sum, that if I want to find the total force on this point O, or we can say on this Q naught, what I should do, I should apply Coulomb's law one by one, and I should add this all forces. So one by one I'll be covering. Let's come at the QA point. QA is a positive charge, and here the Q naught charge is what, 1 microcoulomb, which is also positive. So when 2 positive charges are there and we are trying to find the force between these 2 point charges, then they will repel each other. So if I want to find force on this point QO point due to the QA, it will be repelling this Q naught. So the force will be in this direction. This will be the direction from A to O. So here I can show this force by FA. Let's suppose it is FA, but it is the direction from A to O. This is the direction I can show here. Next is, if I look at the at the B point, the charge which is existing is -5 microcoulomb, which is a negative charge, and since it is a negative charge, and again the point charge at O point is a positive charge, so it will repel or attract. It will attract it because these are two opposite charges, and there is attraction kind of force. So this point QB will be attracting the Q naught, and I can say this, and the force will be in this direction. So I can write here FB. Then there is a charge QC here. QC is again positive charge, similar to the last case A. I can put this direction as a repulsion force. So this force will be in this direction, as both the Q naught and Q are positive charges. I can put this direction, so that will be FC. And similarly, if I look at D point here, D point is again negative charge, so it will be attracting this Q naught like this. So I can put here FD like this. So these are the resultant directions of Coulombs law. The forces by the Coulombs law. Now the point is very important, that if I want to find the exact amount of this force, and the direction is in front of you, and then we will form a vector formation of the forces, and then we'll add them. We'll be going for the vector addition. Obviously you'll be getting some answer. So I'll be what I'm discussing first method is how you can solve this method very quickly, like how you can solve this question very quickly, so that you can save your time in exam. Okay, so the point is what here very important, that first of all you should understand that to find a force, you should get the distance between point charge A and Q naught. So here since I should get this so our first step is in method 1. I'm saying, sorry, in method 1, what I can do, I can start with method 1. So method 1, what I can do, that since I will first find AC, so AC I can write by this formula also. If you look at this triangle, ABC, I can write this here. It will be AD square plus DC square. And now it is very important, it is given in the question that each side of the square is 10 centimeter. So I can write here 10 square plus 10 square. So it will be 10 square plus 10 square, and we'll be finding it is equal to root 2 into 10. So I can write 10 root 2 centimeter. So this is first observation, I can find it. And then what I can do, that since it is very important that due to symmetricity of a square, there is a geometric rule here, that since I can write one rule here, or I can say one result of the geometry only, that that OA is just this distance. OA is nothing but we want to find OA only. OA is the distance from the charge QA to the O. That is you want to find, because in the Coulombs law the distance between 2 point charges are used. So what it will be is just half of the diagonal. So because the diagonals will intersect each other. So here I can write AC upon 2, and this will be 10 root 2 upon 2, which is equal to 5 root 2 centimeter. So your OA will be what? 5 root 2 centimeter. Now the very important point, that since this O point is the center point, so the distance from all other point charges to the Q naught will be also 5 root 2. Why? Because here again I can say, here again this distance OA will be equal to OD, will be equal to OC, will be equal to OB. This all distances will be equal, and this can be written as, let's say, R, and let's say it is equal to 5 root 2, because we have already calculated. So this is one of the things. Now we can say that the distance from each charge to q naught is equal. Okay, so I want to find now the total force on the q naught. So I can write so the total force on q naught is, let's say it is given by f naught is equal to fa plus fp plus fc plus ft, and here we need to consider this in vector form. We need to add them by vector addition. But if you look at this, I'll first explain that if you look at the force fa, which is from a to o, and if you look at the force fc, which is from c to o, both are in opposite direction. So what I will do here, I'll draw some vector direction. Let's suppose this is the point q naught, and as per the above figure, you can say that the force, this is the direction, like the force is going in this direction. So this will be the direction of force fa. I can say it is going like you can check here. uh, this is going from a to b. The direction of force force fa is from a to o side. So I can represent this force like this, fa, and similarly the force fb will be in this direction. So what we can conclude that force, sorry, this is fc. So fa and fc are opposite from each other, and if you know that the formula of force by Coulomb's law is this one, where we just have to include two charges q1 q2 upon 4 pi epsilon naught, and here will be a distance and there is a vector. So if I want to write in the vector form, so I should put q here. So that formula also I had discussed in the last video only. So very important that that if I compare by this formula at fa and fc, and similarly you can find here there are two more forces, which will be this particular force will be fd, and this force will be fp, as they are attraction force. So you can check here from the figure only whatever I drawn. So now the very important point is, when you have fa and fc, both are in opposite direction, fd and fb both are in opposite direction, but if you so you can come to know that the direction will cancel each other. So opposite direction will cancel their effect. But point is, what if I try to find the magnitude? So magnitude of fc and fa will also be equal, and magnitude of fd and fb will also be equal. So the fc will cancel out the effect of fb, and fd will cancel out the effect of fb, and the net force on q naught will be equal to 0. So this is orally I had explained. Also you can, I am just writing some expressions by which also I can show this is 0. So since you know that the char the force formula with vector form like this, so so I can say that here the charge value is 2 microcoulomb. Here the charge value is 2 microcoulomb. Here the charge value is minus 5 microcoulomb. Here the charge value is minus 5 microcoulomb. So if I try to find this force of this force due to this minus 5 microcoulomb on this 1 microcoulomb and minus 5 microcoulomb on 1, so you can check this, that charges are equal. If charges are equal, then the force amount will be also equal. So there will be an equal amount of force in the opposite direction which will cancel each other. So I can say that since what I can say that qa equal to qc equal to 2 microcoulomb, so I can say that what is the formula of fa? Fa is equal to qa as per the Coulomb's law into q naught upon 4 pi epsilon naught, and in the direction will be what? The direction will be it will be ra cube and ra vector. Let's suppose that direction is ra for fa. Okay, and similarly if I write fb, so fb will be not I should write first fc. So it will be qc into q naught upon 4 pi epsilon naught, and then rc vector and upon rc cube. So it is It is very important for us to know that uh, here the distance value, because I have also written that this denominator factor Ra cube Rc cube are nothing but the distance between 2 point charges, and which are given by this value only, 5 root 2. This everything I have written here. So every vector dimension, because you know that the distance between two uh, charges are equal, so you can say that the Fa and Fb are equal. Why? Because again we know that Qa is equal to Qc. So when you put all these equal values, you come to know that this point, this Fa, magnitude of Fa will be equal to Fc, and magnitude of Fb is equal to magnitude of Fp. So the point is, since the magnitude of these forces on this Q naught is equal, but the direction of Fa and Fc are opposite. So I can write one relation in vector form, that Fa will be negative of Fc, and Fb will be negative of Fd. So if I interpret this result of this equation 2 and equation 1, so I can say that the net force on Q naught, net, like F naught, if it is a net force, so Fa plus Fc plus Fb plus Fd. So this first two term will become 0, and this term will become 0, and finally I can write 0. So this is the way you can interpret the result directly 0. So although I have explained it in a very longer time, but if you understand this concept, you can easily solve this sum very quickly. Only the thing is, you will have to know that the distance between point charges to the observation charge is equal for all four charges, and then you can conclude this. The second method which I am going to discuss here is by vector form of the force. So here in this particular method, I need to find the coordinates of each each square point, and then I can use the vector formula of the force, and easily I can prove that the net force on the particular point charge is 0. So what I'll do now, I'll draw this square again so that it will be better denotation. So let's suppose this is a square, and I'm considering now this is point A as usual, this is point B, this is C, and this is D. This D point I am considering on the origin point. So let's suppose this is the horizontal axis X, and this is the vertical axis Y, and now I am considering this is a 0, 0 point. Okay, so it is given that this is 10 centimeter. So if I try to find the location of each point, we can easily determine. So this is 0, 0 on the x-axis. If I go 10 centimeter away in the right direction, it will be 10, 0, 1, 10, 0, and the location of on this point will be 0, 10 as usually, because here the x is 0 and y is 10, and here we can say the this location of B point is 10, 10, because x and y both will be 10. And now we'll locate the center point as usual. As you know, the center point is nothing but the intersection of this point, and if I try to find out the location of this point, what I should do, that I'll trace a perpendicular over here, and let's consider this point is given by E. And what I can do, that if it is intersection point of both the diagonals, so it is also intersecting this, like if I trace a line from this O to DC line, so it is bisecting this DC. So I can say that this half length of DE, and DE will be equal to 5, because it is bisecting it, and also this is 5, I can say. And actually I need to determine the location of this O point. So how I can determine? So earlier we have seen that this distance d to o, distance OD is equal to 5 root 2 as we have seen earlier. Okay, so now we know that this distance is 5 root 2, this is 5. So if I try to determine this height OE, so I can easily find here OE can be given as, by Pythagoras theorem only, I can write 5 root 2 whole square minus 5 square. So if I solve it, so it will be, I'll just take common 5 and it will be 4 minus it will be 4 minus. So if I solve this OE, I can find it here. I can very easily find it, and that 5 under root, like 2 minus 1, and we can find it 5. So again, this particular height is 5. So I can locate this point very easily. What is the x position of this is what 5, I can say, because it is like what is the distance from the from the x-axis here. This point, it is 5 here, and similarly this point is also 5. So I can write this 5. So the location of this O point is 5, 5. Now now point is what we need to use vector notation of the force. Okay, so as I have shown the direction earlier also, so what I'll do, again I'll do the same thing at the Q, like since the Qa is 2 microcoulomb and QB is minus 5 microcoulomb, QC is 2 microcoulomb again, and QD is minus 5 microcoulomb. So here what I can say, that if I have this kind of assembly of the charges, if I want to find the force on Q naught, which is 1 microcoulomb, so again the concept of repulsion and attraction will decide the direction of force actually, and that will decide the direction of the vector which I am going to use. So let's suppose that if it is the QA, then this direction of force, as I have explained earlier, let's suppose this vector is given by RA. Here this direction is given by RA, and in this direction the force Fa is acting on this Q naught, and similarly for this is the vector is given by Rc, the Fc is the force. Here the vector will be in this direction, which is given by Qb, sorry, Rb is the direction where the force is given by Fb, and here it is in just opposite direction, I can say, which is Rd. Rd, I can say that vector, and this force is given by, let's say, Fd. So here one very important concept I am going to show you. If I know, I think that you must know that if I want to find the vector between 2 points, let's say this is x1 and x2, and this is y1, y2. So if I want to find the vector between these 2 points, so if it is in this direction, and let's say this vector is rxy, so the vector rxy will be equal to, always remember, we need to use the concept that endpoint minus starting point. So endpoint minus starting point, when I say, so endpoint is y1 and y2, so I should write y1 minus x1 x coordinate, and plus y2 minus x2 y coordinate. So this is like like an interpretation that how to find a vector. So here what we are going to do, the same approach I'm going to use, since we know that the distance from all charge, like since distance of QA to Q naught, QB to Q naught, QC to Q naught, and QD to Q naught, all are equal. I can say these distances I can give with some variables, let's say RA, RB, RC, and RD, and this all are equal. Let's say all things are equal to r, and we have found this is earlier is 5.2 centimeter. But still I don't have the expression of vectors, because vectors expressions are very important. So I want to find this vector ra. So what will be vector ra? So ra is a vector, like vector from point a to o. So how I should find? So I should mention this point that this is from like 0 to 10, which is point A, and to 5 comma 5, which is from point B. So sorry, O. So if I want to find this particular vector RA, so here by using this earlier notation, I can write the end point, which is 5 minus starting point is 0, x plus end point 5 minus 10 y. So I can find here 5x minus 5y. So this is what vector RA, that is how I can find it. So this is one, let's say equation number 1. Okay, similarly you can also find RB, RC, RD. So um, here I'll find R B vector. So the RB vector is actually um, from if I look at the diagram again, here it is from B to O. So it is from B. Sorry, it is not from B to O. As per the given mentioned direction, it is from O to B. So O to B, as it is attraction force. So it will be from 5 comma 5 to 10 comma 10. So what will be the force? What will be the RB here? I can write 10 minus 5x plus 10 minus 5y. So I can write 5x 5y. Similarly, if I use the same approach for RC also, so I can find this RC vector by endpoint and my starting point approach. So here the endpoint is the point O, which is 5, and the starting point is the point C itself, because it is from C to O. So it is C to O direction. So I can write here this will be 10 comma 0, and it is going towards 5 comma 5. You can check in the figure again. So um, so I'll write this vector, and by just using the same approach, end point minus starting point, it will be 5 minus 10 x plus 5 minus 0 y. I can write here minus 5x plus 5y. And similarly, I can write RD also. RD will be also equal to I can write minus 5x minus 5y if I use the same approach. So now we have all 4 vectors. Also I have directions with this vector, and also I have values of the distance RA, RB, RC and RD 5 root 2. So now suppose I want to find the net force on the Q node. So the total force on Q node is given by as superposition by superposition principle of Coulombs law. I can write Q naught equal to FA plus FB plus FC plus FD. So what I can say that I just have to put the formulas. What will be FA? FA is force on Q naught due to FA. So the formula will be QA Q naught upon 4 pi epsilon naught, and the distance between Q and Q naught is given by, let's say, RA. So it is Q and vector RA. Similarly, I can write the formula FB also, QB Q naught upon 4 pi epsilon naught RB cube and RB vector. Similarly, QC Q naught RC vector upon 4 pi epsilon naught RC cube plus QD Q naught RD vector upon 4 pi epsilon naught RD cube. So we have these formulas, but very important point that here what I can say that since QA equal to QC and QB equal to QD and RA equal to RB equal to RC equal to RD, which is equal to 5 root 2, and these values are 2 microcoulomb and QB equal to QC equal to minus 5 microcoulomb. So when I put all these values in this, if I consider these are equal, so I can simplify this like very easily. That let's suppose that that's QA equal to QC equal to let's say it is Q1 and QB equal to QD equal to, let's suppose it is my Q2, and this entire distance I'm going to consider R. So the above formula can be simplified in very compact form. I can write here, instead of QA I'll be writing Q1 and Q0 as it is, and this will be I'm just considering the magnitude of the vector won't be changing because I cannot change the vector direction here. I'm not saying the vectors are equal, the magnitudes are equal. So 4 pi epsilon naught R cube, okay, and then second term I can write Q2, then Q naught RP vectors upon 4 pi epsilon naught R cube plus Q3, sorry, it will be Q1 Q naught vector RC upon 4 pi epsilon naught R cube plus Q plus Q2 Q naught and then RD upon 4 pi epsilon naught R cube. So when I solve this, so what I can do, I just can take common that Q1 Q naught upon 4 pi epsilon naught R cube, and here it will be what, RA plus RC, and similarly it will be Q2 Q naught upon 4 pi epsilon naught R cube, it will be RB vector RB plus vector RC vector RD. And if you look at above, I had mentioned this vectors, I have found these vectors, and if I'll put these values in the vectors, so you can check it that when I'm this, I'll write this, that when I see, I'll find out these values. Since vector RA plus RC, if I put these values, so I will have to check it again. What is the value? The values are the value of RA is 5x minus 5y, and the value of so if I write it, it will be RA is 5x minus 5y minus 5y, and value of RC is minus 5x plus 5y. So this is going to come 0. Again, if you put the values of RB and RD from the above solution I have done, it is also going to come 0. So when you put these two values over here in the above equation 2, so you will come to know that entire equation will become 0. So total force Ft will be 0, I can say. Why? Because if you put this to vector formation in the equation 2, So let's say equation number 3 and 4. So by equation 2, 3 and 4 I can show that the total force will be 0. So hence you can prove this particular concept, that total force on the center of a square in this condition will be 0. So 0 Newton is the answer. So this is all about this sum, where I have solved this sum by vector geometry also. Let's switch to the next sum. In the next sum, there's a triangle concept. So I'll let you know what is the next sum. Okay, so just we'll read this next sum. Consider the three charges Q1, Q2, Q3 equal to equal to equal to each other. Like they are equal and at a vertices of an equilateral triangle of a side L. The side value of the triangle is L. Then what is the force on the charge Q placed at the center of the triangle? So this is similar to the last sum only. Only the thing is, a triangle is considered over here. So I'm using this geometric interpretation only. Solution. So let's suppose there is a triangle like this, and let's suppose this is point A, this is point B, this is point C. So and the centroid. So if I will come to know what is the definition of centroid. So here we have to consider there are three charges. Let's suppose Q1, Q2, and Q3, and each are equal. Like Q1, Q2, Q3. This the amount of charge on the Q1, Q2, Q3 are equal, and we need to find the force on charge Q, which is at the centroid point. Let's say this is the centroid of this particular equilateral triangle. So let's suppose this charge Q is over here, and the side value is given that L. So what I should consider here, that what is the centroid point, how we can determine the centroid point. So I can say that when you trace, like since it is an equilateral triangle, so let's suppose if I trace a perpendicular from point A to BC. So it is passing from this, because it is a perpendicular on this line BC, and it is also bisecting this particular line BC in L by 2 and L by 2 length. And let's suppose if I again trace the perpendicular from B to AC, so again it is intersecting this other perpendicular, let's say AD and BE. So AD and BD will intersect at the centroid point. And then also if I'll pass sorry, if I'll pass the last perpendicular from point C to the fronted line, which is AB. So again this CF will be intersecting at Q. So this is how you can find out the centroid. So there are some properties which are followed by the centroid. So here I'm writing here that since let's say the centroid is given by point O. So what I can write was, what this is geometric interpretation over here. Say that since O point is centroid of the triangle, and which is an equilateral triangle. So I can say that here this AD is a perpendicular length. So AD, if I say that it is going to divide in AO, and OD. So the ratio of the length of this will be 2:1. So by this ratio I can say that yes, the OD will be equal to 2/3 AD, and not sorry, this is not OD, this is AD. So E will be equal to this, and again OD will be equal to 1/3 AD. So this is all about these cases, and now I need to determine the location of each point, as I want to use the vector geometry over here. So what I should do, let's consider that the B point is at 0, 0. So if I want to find the location of the C point, this will be, let's say this is vertical axis here. So I'm going to consider this as y-axis and this is x-axis. So the C point location can be written as L, 0, and this point location we can easily determine the location of A. So for that we required x value and y value. So x value is already defined, that it is like the distance from the y-axis is given by nothing but L/2. So I can write here L/2, and the y value we don't know. So the height, like distance from the x-axis, but actually we need to find AD. So for finding this AD, what we can use here, since in triangle ADC is equal to this triangle ADC, I can write that so what I can write here, that AD is equal to under root AB square minus BD square. So I can write here that L square minus L/2 to the whole square. So it will be equal to 1 minus 1 upon 4, or it will be root 3/2 L. So this is equal to AD. So the AD height is going to come root 3/2. So I can directly write here root 3/2 L. So we have this location. Now the point is, what is the location of this point O? So for finding this location, again the horizontal value is known. Let's suppose I'm writing over here in the location of O. So horizontal value is L/2, no doubt, but the vertical value I don't know. So to find out this, again I'm using since okay, we know that one rule is there, that OD is equal to 1/3 AD, and since AD is root 3/2 L, so I can write that it is 1/3 into root 3/2 into L. So it will be 1/2 root 3 1/2 root 3 into L. So here OD we can easily determine, and since this OD is L into 1 upon 2 root 3, so I can write here L upon 2 root 3 is the y coordinate of this point. So here if you have all the coordinates, you can easily determine the net force on this point charge Q. So what I can do, since this Q1, Q2 and Q3 all are similar charges, and Q is the little bit different charge. So let's suppose that since all are similar charges, and let's suppose these are positive charges, so the direction of forces will be in the repulsion direction. So I'm considering this kind of directions here, and this is the direction of A. So this is FA, I'm considering, this is FC, I'm considering here, and this will be FB, I'm considering here. Let's suppose for this vector is RB, for this vector is RA, and for this vector is RC. So what I should do here, that 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 we need to find first the vectors RA, RB and RC, and then you can put in the formula. So since now it is very important that since here O is the centroid, so distance from O to A, B and C will be equal. So what I can consider that OA will be equal to OB will be equal to OC will be equal to, let's say, R, and this will be equal to I have determined this, that what I have written earlier, this OA. So OA still we don't have, so this is a questionable thing over here. But since earlier I have concluded one thing, that since OA is equal to 2 by 3 of AD, and AD again we have this value, so AD is equal to 2 by 3 and it is 10 by 2, 3 by 2L, so I can write it, it is 1 by root 3L. So here OA, so I can write that, so I can write this here, the distance R is again equal to L by root 3. Okay, so this is the one point. And the second point is, since the charges QA equal to QB equal to QC equal to Q, let's suppose it's given in the question. So by this kind of symmetricity, we can say that we can say that the force, so the force FA will be equal to FB will be equal to FC, because the charges are equal, distance is equal, so amount of forces on the charge Q will be also equal. So I can write that QA into Q upon 4 pi epsilon naught R square, so that is equal to QB Q 4 pi epsilon naught R square equal to QC Q upon 4 pi epsilon naught R square, and this can be finalized in this term QA into Q upon 4 by epsilon naught R square. So hence we can prove that the amount of charge, amount of force due to all three charges on the centroid charge will be equal, but the direction will be different. The magnitude is equal, but direction are different. So here in this case, I can write one formula here in the vector form, but the vector direction are not same. So one by one I'll be finding the vectors here. What will be vector RA? Is shown in the last question only. I'll be using the endpoint minus starting point concept. So you should know, if I want to find RA vector, so the endpoint is L by 2, 1 by root 2, 3, and this one B point also. So I should write these points again, so that I can clearly find out. Sorry, I can clearly find out this particular RA, RB and RC. So it will be I just want to find look at the points here, because these are the 3 points, and let's suppose this is the central point. It is 0 0, it is L0, and this point is L by 2 and root 3 by 2 L, and this point is L by 2 and 1 by 2 root 3 L. So if I this point, let's say this is point A, this is point B, and this is point B actually, and this is point C. So what will be the vector RA if I want to find? So this will be the end point minus starting point, so it will be L by 2, like L by 2 minus L by 2, L by 2 minus L by 2 x plus 1 by 2 root 3 L minus root 3 by 2 L y. Similarly, you can find RB. So this RB will be in this direction here. So it will be L by 2 endpoint minus starting point x plus 1 upon 2 root 3 L minus 0 y. And RC here is this is the direction of RC. So it will be L minus L by 2 x plus 0 minus, sorry, I have written something wrong. I should use end minus starting point approach. So it will be L by 2 minus L x, and the second is I should write 1 upon 2 root 3 L minus 0 y. So like we have these three vector forms, and now what I'll do, I'll simplify them. Like RA is equal to 1 upon 2 root 3 L minus root 3 by 2 L y only. Then I'll write RB, it is equal to L by 2x plus 1 upon 2 root 3 L y, and RC is equal to minus L by 2 x plus 1 by 2 root 3 y. Okay, so now we have the vector forms in this three equation. Let's say this entire equation is equation number A, and now what we can see that since there are three charges and we need to find the charge on the force on a certain charge which is at the centroid, so the net force on centroid is given by, let's say, FO, which is equal to FA plus FB plus FC. And it is very important that when I say that and this is in a vector form, so everything is in a vector form, and you know that their magnitudes, like if I put the formulas, so it will be Q, like I'll just write the formulas here. Here that is what Q naught QA. So you know that QA, earlier I have proved it, that each force magnitudes are equal but their directions are different. So I can write this term by earlier expression equal to, directly I can write the Q naught, sorry, Q into only Q, or I'll repeat this task again here. What I'll do, Q Q naught QA upon 4 pi epsilon naught, and the distance I'm considering as equal, there will be RA vector, and this will be for QB and QB RB, and 4 pi epsilon naught RQ, and Q naught QC RC vector upon 4 pi epsilon naught RQ. And you know that QA equal to QB equal to QC, these are equal as I explained earlier. So this part can be taken common because I'm taking this entire part common, as I know that QA equal to QB equal to QC, these are equal. So since these are equal, I can put this common, and similarly here is the RA plus vector RB and plus vector RC. Now if you look at equation A, and when you add these vectors, so you can easily say that when you add this RA plus RB plus RC, so this will cancel each other, and this will also going to cancel. When you add, you can check by addition, vector addition. So the vector addition of these three is going to come 0. So hence I can say that the net force on this centroid by these three equal charges will be 0. So hence I have proved it that again the net force on the centroid of the triangle, equilateral triangle, will be 0 when each charge is equal. So it is enough for today's lecture. If you have any doubt, you can write a comment in the below chat box. I'll try my best to reply, and if you like my lecture, please give me a thumbs up. And if you are not subscribed my lecture till now, please subscribe it so that you will be getting the notification of all upcoming videos. Thank you. Thanks a lot.